Dear children, in the previous class, I have explained you about the intermolecular forces and thermal energy, that how these two factors decides the states of a matter. In the unit 5 of class 11th, we will study in detail about the gaseous state. In the periodic table, you must have been explained that the gases of the periodic table lies in the P block. The gaseous state, we have already studied that these gases are highly compressible, the intermolecular forces between the particles is very large, they do not have the fixed shape and fixed volume. They can take the shape of any container. Let's study first of all the general properties of the gaseous state. This is the simplest state of matter. The physical properties: gases are highly compressible, gases exert pressure equally in all directions, gases have much lower density than the solids and the liquids, gases mix evenly and completely in all proportion without any mechanical aid. Simplicity is due to the fact of gases, the forces of attraction between their molecules are negligible. We can predict the behavior of the gases based on the following properties: pressure, volume, amount, that is moles, and temperature. Pressure. Pressure is defined as the force the gas exerts on a given area of the container in which it is contained. The SI unit for pressure is pascals, symbol PA. The other property we must define is volume. Volume is the three-dimensional space inside the container holding the gas. The SI unit for volume is the cubic meter, that is meter cube. A more common and convenient unit is liter, symbol is L. Amount or the mole. To define amount or the mole, first of all, we must know what is 1 mole. You have studied in unit 1 that 1 mole is equals to the collection of 6.023 into 10 raised to power 23 particles. These particles can be atoms or molecules or ions. It is also known as Avogadro's number. The SI unit for amount of the substance is the mole. Since we cannot count the molecules, we can convert measured mass in kg to the number of the moles small n using the molecular or formula weight of the gas. By definition, 1 mole of a substance contains approximately 6.022 into 10 raised to power 23 particles of the substance. Temperature. Temperature is defined as degree of hotness or coldness of the body. For these lessons, we will be using temperature measurements in Kelvin, symbol K. The Kelvin scale starts at absolute zero, which is minus 273.15 degrees Celsius. To convert Celsius to Kelvin, add 273.15 degrees. How do they all relate? How pressure, temperature, volume and amount, that is number of moles, are related? They are related through gas laws. The gas laws which we will study now are the result of research carried out on for several centuries on the physical properties of gases. The first law is the Boyle's law. It is the relationship between pressure and volume. As per this law, pressure and volume are inversely related. Inversely related means if the volume increases, the pressure will decrease, and if volume will decrease, the pressure will increase. Let us define Boyle's law. Boyle's law states that at constant temperature for a fixed mass, the absolute pressure and the volume of a gas are inversely proportional. On the basis of his experiment Robert Boyle reached to the conclusion that mathematically it can be written as pressure inversely proportional to volume at constant temperature and number of moles. K1 here is the proportionality constant. The mathematical equation for the Boyle's law is PV equals to K, where P is pressure, V is volume and K is proportionality constant. Now you can see the graph here. It is plotted between the pressure and the volume. As the volume is increasing, there is a decrease in the pressure. This graph also shows that pressure is inversely proportional to volume. The next law is Charles' law. Charles' law relates volume and temperature when pressure and the number of moles or the mass of the gas is constant. As per this law, volume is directly proportional to temperature. Let us define Charles' law. At constant pressure, the volume of a given mass of an ideal gas increases or decreases by the same factor as its temperature on the absolute temperature scale, that is, the gas expands as the temperature increases, which can be written as volume directly proportional to temperature. Directly proportional means as the temperature increases, volume will also increase. Add 273 to the Celsius temperature to obtain temperature at Kelvin scale. Charles' law states that pressure remaining constant, the volume of a fixed mass of a gas is directly proportional to its absolute temperature. This is the graph between temperature and volume keeping pressure constant. You can see the straight lines. That shows when the temperature is increasing, volume is also increasing. Isobar. This graph is also known as isobar because we are keeping the pressure constant. Absolute zero. The lowest hypothetical temperature at which gases are supposed to occupy zero volume is called absolute zero. The third law is the Gay-Lussac's law. This law correlates pressure and temperature when volume and the mass of the gas is constant. As per this law, pressure is directly proportional to temperature. Let me define the mathematical relationship between pressure and temperature. It states that at constant volume, pressure of a fixed amount of the gas varies directly with the temperature. Mathematically, P is directly proportional to T. P upon T is equals to constant, and here the constant is K3. The graph, when plotted between pressure and volume and keeping temperature constant, such graphs are known as isotherm. So we have three types of graphs: isobars, isotherms and isocores. The fourth law is the Avogadro's law. It correlates volume of the gas and the number of the moles of the gases when the temperature and pressure are constant. As per this law also, the volume is directly proportional to the number of the moles of the gas. Let's define. It states that equal volumes of all gases under the same condition of temperature and pressure contain equal number of molecules. Mathematically, we can write V directly proportional to N, where small n is the number of the moles of the gas and V is volume. V equals to K4N. Here K4 is the proportionality constant of Avogadro's law. Avogadro's constant. The number of the molecules in 1 mole of a gas has been determined to be 6.022 into 10 raised to power 23 and is known as Avogadro's constant. Since the volume of a gas is directly proportional to the number of the moles, 1 mole of each gas at standard temperature and pressure, that is known as STP, will have the same volume. Dear children, just now we have studied about the general characteristics of the gas and the pressure, temperature, volume and the number of the moles must be defined to study the behavior of the gas. We also studied the 4 gas laws, which defines the relationship between pressure, volume, temperature and the number of the moles. These laws were the Boyle's law, Charles' law, Gay-Lussac's law and Avogadro's law. We also studied about the 3 graphs, isotherm, isobar and isochore. I hope all these graphs and all these gas laws are clear to you.